Welcome. So today we're here to show you an introduction to commissioning the NX6100. So it isn't that difficult if you have the know-how. So today I'm with Richard Long. He's another product manager here at FireEye, and we're going to be working together to demonstrate this process. So I'm going to start by going to our website. So let me bring that up. So at FireEye.com, we have all the resources you need to get started. So I'm going to start by going to Burner Controls from the Products tab. Then I'm going to scroll down to Efficiency Control section, and we have an NX6100 parallel positioning section. I'm going to click that. What I'm looking for right now is a document called the Minimum Option Parameter Settings. We do also have other important documents such as the bulletins or the manuals. NX6100 is the NX6100 main bulletin, and that has all of the parameters and all the information it's about a 100+ page manual. But what we want to do is go down to Service Guide, and under that tab we have the NX6100 PPC 6000 Minimum Operation Parameter Settings Setup. So this is a PDF, and this is what we're going to be referring to. So the other document that we're going to use is actually go back to the Products tab under Burner Controls. This is in the NXF4000 section. So I'll click on that. And down in the Service Guide section for the NXF4000, we do have a generic Nexus commissioning worksheet for gas fuels. This is an Excel spreadsheet that we're going to use. It's going to help us determine the servo positions as we set up. And we're going to be using that as our guidelines for where we set the servos. So I already have that downloaded, but that is where we would get that from. So let's go to the touchscreen for the NX6100. Let me bring that up. Okay, so we're here at the touchscreen for the NX6100 now. This is the way it's going to come when it's new. When you first turn it on, this is the screen you're going to see. So it's not ready to use, it's locked out. So Richard, how do we get started with this commissioning process from here?
Okay, well the first thing, as you can see, you're going to see on the touch screen that you have an F18 fault. That's too few set points. That's what you would expect to see with the control out of the box. So what we're going to do here is we're going to go to Menu, and then Menu we're going to go to Burner Settings. Burner Settings, we're going to hit COM, and then we're going to enter the passcode. And your screen should turn red. So you are now in the commissioning mode of the Nexus. So at this point, we could go look at our drives, and we'd see that our drives are zeroed out.
So for the NX6100, in this case, drives means not a VFD necessarily, but it means any servo, correct?
Correct, and a drive can also be a VFD.
So it's a channel of operation. It can be a servo or it can be a VSD.
Just going through the tabs here, now you can look at your options. This is where you're going to go and set up the minimum option parameters that Carlo showed you on the FireEye website under the NX6100 tab. You can go select that and enter the data here, and this will get in this case, the trainer running, but the boiler running. But these are minimum option parameters just to get you going. More for testing, not so much for starting up a boiler, because there's additional safeties that you would want to enter as well.
Yeah, so this is just the minimum option parameters to get going.
Then we can see our engineering values. Those are good, a good tool to go in and see what digital inputs you might have on and off. And then you can select your profiles. In this case, you're not going to see anything here. So we can get started here on commissioning the boiler. The first thing I'm going to do is want to set the option parameters. So I'm going to set options. Then I'll go ahead and scroll up here to the top. And I'll just simply start going through and entering the minimum option parameters that we took off the website. So the first one is going to be 2.0, and so we'll scroll to 2.0, and this is where we're going to be naming the drives. So in 2.0 we're going to name 10.
So this isn't just where you name the drive, this is where you select what it does. and we're going to be choosing 10, and 10 corresponds to it's an air servo, for example.
In this case, 10 does.
So you would refer to the NX6100 to get the definitions of what 10 is, what an air drive would be, what a gas drive would be, for example.
So in this case, for this exercise, we're going to have a air drive, which is going to be 10, and we're going to have a fuel drive, which is going to be option 2.2. Hit set. We're going to select 2, and 2 is the designation for gas. And again, as Carlos says, you'll be able to find this in the manual as you go along.
So drive 0 is an air servo, drive 2 is a gas servo, right, so far?
Correct.
Okay.
Now we've gone through and we told it what the name's going to be. As you can see over in the right-hand column, it still says drive 1 name, drive 2 name. You won't see the air and the gas come up until we get into the commissioning part. That'll become clear, and we'll mention that again as we go. So the next thing we need to do is go to the 3.0, and we have to select the appropriate serial number. And so there's your serial numbers on the top, and it really doesn't matter which one we select for this exercise, but we'll call that first one is going to...
It's getting the serial numbers from the CAN bus. It's going and discovering what's available.
The next one we'll select is 3.2.
Do you want to make sure you don't choose the same one again?
Correct.
I think that's what you just chose. Yeah, there you go.
And so now we've assigned the serial number to the air and the gas drive, and the next thing we have to do is tell it what drive we want it, what profile we want it to use with. That will be selected in the 4s. So we'll do 4.0, set. And if we pick 15, that will mean that it will work with all drives, all profiles, all drives with all profiles.
And this is explained also in the bulletin, but you can see where it says +1/2/4/8. So there's 4 available profiles. What they're saying is the number you put in, if you want to use it on profile 1, it's going to be +1, +2, +4, +8. So for all of them, 1 +2 +4 +8 does equal 15. So if you just wanted it on 1 and 2, for example, you would put a 3 because that's 1 + 2.
Correct. Now we're going to go select the drive direction in 5.0 and 5.2. So we'll hit set again. 0 is the default, so we're going to leave that alone.
So it's going to explain whether is it 0 or 1 are the choices for clockwise, counterclockwise.
0 and 1, yes.
So it's going to explain which is counterclockwise and which is clockwise in the bulletin as well. And the bulletin is laid out. All these option numbers go sequentially, and the bulletin is really laid out from top to bottom with the option numbers, because the option numbers are how you set everything up. Instead of it being menu driven, it's driven by these option numbers, and the bulletin goes through all of the option numbers to explain what they do. So if you need to know what option 5.0 is, you can find the section for option 5.0 very clearly in the bulletin, and it will explain the choices.
Correct. So the 2s, the 3s, the 4s, and the 5s all go together, all have to have a value in order to have the servos operate correctly. So the next step is 6.1. We're going to select, and that's where you name what profile you want, what you want your profile name. In this case, we're doing gas only, so we're going to select 1 for fuel. Now we skip all the way down to 12.0. And this is where we select your scanner type. So in this case, for the trainer, we will select 1. But if you were going to be doing an infrared scanner, you would select 2. If you needed a UV, you would go down to 13 and select a UV type scanner there. But for today, this is what we're going to enter.
So 1 is for a direct coupled scanner, which is how the trainer simulates a flame, basically.
Now we've entered that. We'll go to 15.0. And this is where we select our sensor type. Again, all this is in the manual. You would have covered this already. And
MV stands for main variable. Or that's like the process variable. That's going to be your steam pressure or your water temperature.
15.1, we'd go in, and its default is 0. That's for 0 decimal place.
That's the resolution of your main variable if you wanted to see your PSI with a decimal point or not, for example.
15.2 is your input 0 span, so that was going to leave at 0. And then 15.3 is going to be your span, which in this case we're going to set 200.
Yeah, so if you were using a sensor that was 0 to 200 psi, your 0 number would be the 0, and your span would be the 200. If you happen to be using one that went below 0, your 0 number could be something else, or above 0 as well. So this is where you range your sensor.
15.4 is where we'll select 0 for PSI, so we'll leave that alone. But if we wanted bars, for instance, there would be another value, 1, 2, and different engineering values that you would be able to put in how you want it to read. In this case, we want PSI. So 15.5 is where we'll set our high limit. .20 is where we're going to do PID enable. And that will be set for 1.
And this is for the internal load control function, so that it can control the firing rate with the sensor directly.
21.0 is going to be your control value, your set point. .22, 21.2 will be your proportional band. We'll select 10 here. .5 will be your control limit, set point 1 control limit. And 21.6 will be your cut in.
And this is a little different than the 4000 in that you put absolute values like 95.
And you can do that here as well, but you would have to select absolute.
Okay, that was the previous option. I see. Okay, so it's going to explain that better in the bulletin, but you can choose either way to have it offset of the set point or have absolute cut in and cut out values. Okay.
So there you have it. You have enough option parameters in order to test your system, get up and make sure that you're running and really start putting a program in. Obviously, if you're in the field commissioning a boiler, you'd want to option in your safeties, but this is enough to get you going. Option your safeties in, and then we can go ahead and start the commissioning.
Okay, so now we're ready to start the commissioning. So what do we do next now that we have the options in that we need to do?
Okay, so we were in options. We'll just go up and select the drive tab.
Okay, now we see some values.
Now we see some values.
So something quick to go over is with the CAN bus servos that we have, they do have switches, physical switches, which is a little different than the 4000 series that doesn't, but you don't actually have to set them, correct?
That's correct. I prefer and tell our OEMs, if you're getting a piece of equipment from an OEM and they've come, hopefully they haven't touched the end switches. That they have, they probably had a good reason to do it. But when you get them in, you don't need to mess with the end switches. You simply leave them as they are, and then you should be able to commission without any issues.
Okay.
So now what you have to do, one is, remember I said that you have C18 too few set points. Well, you cannot commission the boiler with any faults. So in this case, we would hit the fault mute key, and we should be able to clear that fault. And we see that it did clear and it goes green.
So how did you clear it? So you pressed it once to mute and then you held it down for a certain amount of time to clear?
So, correct. You have to keep in mind that if you just temporarily, if you have a fault, your horn will be going off in the background. If you momentarily hit the reset button, it will clear the horn. So it'll stop the horn so you can figure out what's going on. But in order to actually clear the fault, you will have to hold the reset button for more than 3 seconds.
Okay.
And then you'll have a cue come back, you let go, you see your green light come back. That means you're ready to go ahead and start the burner. Again, keep in mind, you can't go in and get into the commissioning mode, that is, get the red screen, if the burner switch is on. So you want to turn the burner switch off. That's a mistake that's commonly made and calls that we commonly get.
Okay, so
So now we turn the burner switch on. We're going to start commissioning. You can see that we're at P0. P0 is your damper close position. So at this point, I'm going to want to make sure that my servos work. So I'm going to run them down as low as I can, come up a tick or two, and then I'm going to bring it back down and maybe come up to 1 degree. It's close enough. Then I'll switch over to my gas and I'll run that down to the, and this is running down to the end switch. And I'll come up a little bit. I just don't like to be sitting on the end switches. For this purpose, this is fine.
So one thing here is a little different again from the 4000, just a difference. Not better or worse, but it doesn't require you to do a modify save. It changes as you press the button, correct?
Correct.
And we also have the fine adjust button, which allows you every button press to be a little bit less if you really need to try to fine tune your position.
Correct.
Okay.
So at this point, if that's the position that you want your servos at, but in this case your air and your gas, you would hit enter. And that's going to start, you're going to hear your blower motor come on now, and you're going to know your burner is running. And it's going to say moving drives, please wait. That's normal. It's just going down to check the end switches.
Okay, before we get too much further, let me go back to our commissioning worksheet, because we forgot to fill that out for point 0, but we haven't gotten very far yet, so let's go to that. So let me switch over. So our commissioning worksheet that we had downloaded before, this is what it is. So this is a commissioning worksheet for gas fuels, and the purpose of this is to help you with your commissioning so that you make sure that you have the proper gas rate, so you have the right turn down, you have the right output, which helps the PID to do its job correctly. And we're going to have a WebEx on that in a couple of weeks, but so there'll be more information as to why. But for right now, we're just going to go through the steps on this worksheet. And the first step is that we would fill out just the site information. So we're going to write that this is the video test, FireEye serial number 1234. So you'd fill out some information on the sheet so that you can save it for your records. So you would then for step 1, you would check your servo addressing and direction. We've done all of that already. So step 2 is to set the standpipe positions, which we just did. We're using an air and a gas servo. So we're going to we set the air servo for what? It was 1.9 or so. And we set the gas for like 1.6. So we're now moved on to step 2, which is to set P1 to have the air influencing servos at the maximum position. Is this which position are we at right now? P1.
We're still at P0, but it's registering P1. It wants us to drive up to the damper open position.
Okay, so that's the same position as what the worksheet says. So this is going to be the position where we would purge at.
Correct.
Okay, so now let me go back to the screen real quick, and then we'll set that. All right, so let's set the position for P1.
So as you can see, the gas is highlighted. You can leave your gas at the bottom. So all we're going to do is drive our air up. So as we drive up here, you'll see the values change. We'll drive up to, in this case, full damper open is going to be 80. So 83.7, and we'll enter that.
Okay, so now before we move on, we'll go back to our worksheet and we'll put these numbers in so we can keep up with that. So this was actually, I had these a little off. It was 0.5 and 0.4, I believe. It's not super important for the test, but you'd fill in the standby positions. And then we had 83.7 for the air and 0.4 for the gas because we didn't move that for the standby. And now the next step here would be when we go to P2. P2 is the ignition position?
That's correct.
Okay, so we're in position to go back to the next screen. and we'll enter that information. But for the ignition position, now that we've hit next, it's going to have to purge and everything, correct?
No, we now have finished our purge, so we can now drive to the P2 position.
Okay.
As Carlo was talking, when I drove up to the P1 position, learned the 83.7, then it did its purge, and then it grays out P01, and then P01 becomes green. It switches to P position 2.
So now it's ready for us to set the ignition position. It already purged.
Correct.
So now this is where we would set the ignition position.
So I'll start running our air down to a pilot ignition position. And that's about where we're going to do it for this test, and then we're going to switch over to the gas. Obviously, we're going to have to bring it up some in order to get in ignition. And we'll just, for the test, that's where we're going to leave it here today. So at this point, I'll hit enter.
Okay, so now it's going to drive to those positions and actually ignite the pilot.
Not yet.
Not yet?
Not until we hit the next button. Okay. However, if you wanted to adjust this at this point, you could. You haven't lit off yet, but you can make changes until you hit next. So if we hit the next key, it's going to come up and ask, do you want to ignite now? And if you feel comfortable, you go ahead and hit ignite now.
All right, so I'm going to go back. Well, before we do the next position, let's go put these in. All right, so let's go back to our worksheet, and we're going to fill in those ignition positions we just determined, 18.4, and what was the gas, 14.6. Okay. Scroll down a little so we can see the next section. So the next section here is going to be for us to, we're going to finish what we're doing with the ignition, but the next section is going to be for us to drive the servos to the high fire position so that we can set our gas input flow. So what we're going to do when we actually light off and we get to what should be the low fire position, instead of setting the low fire position, we're going to drive the servos up so that we could get to where our high fire would be, make sure our regulator is delivering enough gas that we're hitting our rate. We're going to record the servo positions at that point into the spreadsheet. Then we're actually going to drive them back down and set the actual low fire. So right now we're in position on the spreadsheet to do that. So let's go back to the NX6100 and actually do this. Okay, so now we're back here.
So Carlo liked the position of his pilot. If in fact you didn't like quite the way your pilot was burning, here at P2, which is your ignition position, opens your pilot fuel valve. Now, if you wanted, you could adjust it, but we like it. But if you wanted to adjust it, then you would move it up or down, the gas or the air, to get the pilot that is desirable. And at that point, it would make you re-enter it. So you have the opportunity here to adjust your pilot.
That's a nice feature.
In this case, we're going to go ahead and hit next to go to P3. And now it says, do you want to ignite your main fuel valves? Yes. Saying moving drives, please wait. So it takes, just be patient here. When you're using the touch screen, it gives you a lot of information. And now it just told me that it accepted it and it's happy. At this point, I can go ahead and move. We're still at P2. All we did was open up our main fuel valves. So at this point, if we hit next, it moves us to P3. Now you can see P3 is the same as P2 at this point. If we wanted to keep it the same, we can. If we like that as our low fire, we can actually make it lower to get better turn down, or we can raise it up a bit. So it just depends on how your burner operates, and that's how you would choose what you want to do with P3.
So yeah, so we have an independent ignition position, as you mentioned. You can change it if you need to. Some burners will light better at a higher output, and then you want to lower it for low fire for turn down. So P2, it gives you the opportunity at many stages to adjust P2. Now, once you're in automatic, P2, of course, is just one setting. But for now, we did have several stages to adjust P2 if we needed to. I put it in the spreadsheet right at the beginning, but if we had adjusted it, I would have made a change. But right now that we're at P3, what we're going to do, and we're going to do it a little faster than you would do it in real life, with an analyzer hooked up. In order to get to the position where you would be able to adjust your regulator at high fire, it would be a little bit slow going, where you would move the air and the fuel a little at a time. We'll kind of do that, but we're going to get to the position that we're basically going to use later for high fire. We're going to pretend check our pretend gas regulator to make sure we make our rate, whatever that rate is, and then we're going to set what we want our low fire to be. And ideally, you would have a way to verify that your turn down was correct, and you'd be able to check the rate at low fire as well. So if you were supposed to have 10 to 1 turn down, 5 to 1 turn down, whatever it was, that your low fire was in fact that much lower than your high fire. So right now, let's go to a sample high fire position at P3 just to record the numbers. Now we're going to make sure we never hit next when we do this, because we don't want to save this as P3. We just want to drive the air and gas to where the gas would be high fire.
We do this in steps. Right now I'm just running it all the way up in order to speed up the process, but you'd want to just step it up as you normally would tuning a boiler to do this.
Okay, so that's good for air.
We'll call the gas about 50%.
Right, so we're going to take the gas to about 50%, and then we're going to go back to the spreadsheet.
And again, you would never do this in real life. If we were doing this on a trainer, we would run these up in increments, comfortable, just step the boiler up, obviously, and get up to the point to be able to enter the high fire
So don't enter it
PX
yet.
position.
We're not going to enter it.
That's right.
Okay, so I'll put those numbers in, 82.7. So right now what we're going to be doing is we're going to be verifying this by either clocking the meter or using a gas flow meter, which would be the easier way to do it if you had one. So the spreadsheet gives you a place to put in the burner rated output. So if we had a 20 million BTU burner, we would put 20 here. And let's say at high fire we're reading 7 inches of burner head pressure. Our heating value gas is 1,050 BTUs. We'll leave that in. And let's say we had a turn down ratio of 4 to 1. And our boiler was 83% efficient. So I'll fill in some numbers here. These numbers are going to help with the second half of the spreadsheet, where we're going to actually fill out the rest of the curve. But for right now that we've recorded those numbers, what we're actually going to do is, while we're still in P3, we're going to actually set low fire where we need it to be. So let's say we clocked our meter and we got it right for 20. So we're at 20 million BTU. We're at the proper output. So we're at 4 to 1. So we'd want to get to 5 million for low fire. So we would be checking that we were at 5 million for low fire with the settings that we're going to choose now. So let's go back to the NX6100 and set this to the actual position where we would want low fire to be.
So again, we would be alternately going back between gas and air and stepping it down in stages in order to get it back to our P03 low fire position. But I'm just going to go ahead and race on down. Obviously, what would happen is get back to our P3 position. And what was that? What number do you want there, Carl?
Oh, it can be...
What were we? Just higher than that?
Yeah, we could set the gas at like 10% and the air at, say, 15.
Okay.
For the example, anything's going to work. That's good. So now, with the gas set at 13 degrees, we verified that our output was where it should be by clocking the meter again at low fire or by having a gas flow meter. So we know our turn down is going to be correct because we have the proper amount of gas flow. So that's good right there. So the numbers we have now, so now we're set to our actual low fire, and it is correct for our turn down. So let's put those numbers in. So the air is 26.1. I'm not going to hit any buttons yet, so we'll just stay there for the moment. Okay, so now that we've set that, we're going to go over to this side of the spreadsheet where it's going to show, it's going to have the instructions to set P4 through P12 using this chart. So we have some settings at the bottom for butterfly. So if the valve you're controlling with the servo is a butterfly valve, you'll want to check this because a butterfly valve works differently. Its curve properties are different than a different kind of valve that's going to be linear. A butterfly valve has a polynomial curve. So we're going to want to check butterfly for the gas because it is a butterfly valve on the gas. So it's going to change the positions we're shooting for. Now this shows you the fuel flow that you're trying to achieve at every position. So if you have a fuel flow meter, the easiest thing to do is to just read that you have that amount of fuel flow at every position. We're going to be trying to target the servo to get the gas fuel flow correct, and then we're going to trim the air to get good combustion numbers. So we want the gas to be perfect so that our curve is linear for the gas, so that 50% output is going to be 50%, or 1 million BTU, or 10 million BTU in this case. But if you don't have a fuel flow meter, we're going to use the burner head for an approximation. So right now we're going to go back real quick to save 0.3 and move on to 0.4, and then we'll come back to this briefly. So let's save 0.3.
So we'll enter
And this
P3.
Yeah, so this will take us to 0.4, correct? Okay.
Correct. It's good, and it's moving servos. It's moved servos. P4 is turned green from red. That means now we can put the values in out of the spreadsheet.
Okay, correct. So right now we're running in auto. Not an auto. We're running we're done with main. We've lit off and everything. We're in commissioning. But we don't have to worry about running out of load. We have an infinite amount of load in the test lab. So in reality, you might have some issues with having to work a little quicker than we've been doing because you'd run out of load. But now that we're at 0.4, let's go back to the spreadsheet and see what we'd have to put in for this point. So right now, what we're going to do is we're going to look at the targets, and these are just guidelines. Now the main one we want to do is the target for the gas, and what we'd actually be trying to measure is that we have 0.78 inches of burner head pressure. And we check butterfly, so it's accounting for the curve of a butterfly valve, which is going to be about half open at 60% instead of 50%. So let's take that to 20.2, and the errors target is 32.4. So while you start doing that, I'll go back to the NX6100 screen. So, and of course, you'd want to be doing this in such a manner that you didn't run into any issues with the combustion. So setting the gas to 20.2 should yield the proper amount of fuel flow to stay on our curve. And then we would actually trim the air to make sure that we had good combustion analyzer numbers, good O2 numbers, basically. So the gas is going to go to 20.2. And we can just get, for the gas, it's more important that the gas is accurate because that's going to be your actual fuel flow. So, and that's decent. Okay, we don't have to be perfect. So let's put those numbers in. All right, so I'm going to type these in offline, and I'll just read the numbers off the spreadsheet.
And Carlo mentioned earlier, if you have an issue with load, once you get to P03 and save P03, if anything were to happen, a safety were to open, or you meet your pressure requirement or hot water requirement, at that point, it's going to retain everything below that position. You could simply wait and go back into commissioning, next through, get the P04 in that case, and then just start your commissioning process on again.
Right, it'll remember the points that you finished commissioning and let you step through them right back to where you were. And the NX4000, PPC 4000 work the same way as well. So now we're at 0.5. So our guidelines here are 38.7 for the air and 26.0 for the gas. And can't reiterate this enough, but to stay on the curve, according to the spreadsheet anyway, where you're trying to get your linear output.
Gas, you like what?
The gas is going to be 26.0. You do want to make sure that the gas numbers are as close as possible to achieve your target burner head pressure or your fuel flow. So yeah, those are what you're using to verify your gas output. Because if you don't use anything to try to verify that you're setting up the gas in a linear manner, your output is not going to be able to be controlled easily by the PID, because 100% might be the most you're going to get, but you don't even know if that's going to make rate, or if you don't know if that's going to make rate, or if 50% is really half. So without using something as a template, as a guideline to go through, which this spreadsheet helps make easier, you don't really know if your output is accurate to anything. So let me put these numbers in. So we're at 38.2 and 26.5. And our next, so we can save that point, and our next point is 45 and 30.8. Well, Richard puts those numbers in. I'll just show you the spreadsheet again, just that we show you where we're at right now. And you can see I've entered a few of those numbers in here as we go. I'm putting them in this column. So the target is your guideline. You don't change that. We're putting in the actuals here. So
45 on the air.
45 on the air, 30.8. Yep. Okay. So we did that. So you can save that point. And our next one is going to be 51.3 on the air and 34.8 on the gas.
$51.8.
51.3. So again, if you're confused about what we're shooting for the gas, if you have a fuel flow meter, it's very easy. We're looking for this fuel flow number, and that's 30.8 on the gas. Okay, so let's wait a second. I'll put that in. But if
I didn't move the gas yet.
Okay. Oh, it's 34.8. But if you don't have your fuel flow meter, the burner head is what you're reading. We read it at high fire when we went up to high fire at the beginning to set our rate and clock the meter. And it's been calculated what the burner head pressure should approximately be at every other firing rate. So we're using that to approximate that our gas is where we want it to be.
So we're at 34.7 on the gas and 51.3 on the air.
Okay, so we've set that position. So we can move on to the next one. And that will be 57.5 for the air and 38.2 for the gas. And the other nice thing about the spreadsheet is that it's going to have the right amount, I think the right amount of positions. So we have P3 through P12, so you don't have to just randomly decide how many points to put in. It's just laid out for you. It takes a lot of the guesswork out of commissioning. Would you agree, Richard? Sometimes with commissioning, it's a little bit, you don't really exactly know how many points you're going to put in. You don't really have, it's easier to go into it with a game plan.
That's correct. 57 point.
And you're going to be making adjustments as needed, of course, to get good combustion numbers, and to, if the burner head pressure isn't quite right at the target setting, you're going to make small adjustments. But just to get better combustion, you don't want to adjust the gas. You want to always trim the air to, if your combustion numbers aren't quite where you want them to be. Because otherwise, if you trim the gas, you're going to affect your rate. So we have 38.4 here, so let me put these in. So our next point, we're ready for that. It's 63.8 and 41.2.
63.8?
Yes. So now we're more than halfway done going through the points. Okay, that's good. Or that's close.
What do you want?
63.8, sorry.
Okay.
Thought it was good. All right. 41.2. All right, so now we're just about to enter 0.9. So I think that's good right there. All right, so we've just confirmed 0.9. And we're moving on to 0.10. And we're only going up to 0.12, so this is good. So 0.10 is going to be 70.1 for the air is a target. 43.8 is our target for the gas. Okay, we're almost there. 70.1. Let's say that's good. 70.6 and 43.9. Okay, so let's go to 0.11. And this one's going to be 76.4 and 46.3 for targets. And as we've been going, we've been checking our virtual burner head, and we've been determining that we're good. So,
in addition to checking our analyzer.
yeah, our pretend analyzer as well. All right, so we're not going to hit next when we're done with this one. We're going to wait a second, but we're just going to put the numbers in we need. Okay, so that's good enough. Okay, so before we hit next, let's go back to the spreadsheet so we can review what we're going to do for our last point. So I've put in all the points that we have so far. Okay, so the spreadsheet's almost complete. Actually, it looks like it is complete, but we haven't finished entering them all yet. Now notice that in point 12, it's already got numbers filled in. Those are the numbers that we filled in earlier when we did step 5, when we drove it to high fire when we were actually at low fire, and we recorded the high fire numbers. Those are the same numbers we're going to re-enter for point 12. And the reason that we're going to do that is because then our rate's going to still be the same as it was before when we clocked it. Now, of course, we didn't adjust the gas pressure or anything when we were doing this, otherwise it wouldn't be relative anymore. But those, we're going to put those same positions back in. So those are going to be, we'll write this down, those are going to be 82.7 and 49.4 as you see on the bottom here. So let's go back to the screen, and we'll before we move on. So right now we're back to the screen. We can hit enter for point 11, and it'll go to point 12. How many points can you actually go up to if you want to, Richard?
Well, you can have a total of 24 positions. So your first, 20.
So right, so we could actually have more than 12. This is going to be our last one, but you can have up to, as you said, up to 20 additional on the curve points. So right now we're going to put in those numbers, 82.7 and 49.4 for the gas. That's perfect. That almost was. Okay, but we're going to end it a little bit differently this time. We're not going to hit next. Is that correct? So let's let Richard get that set. Before you hit anything, let's explain what we're going to do next. We're almost there. 82.7 is what we're going for. All right, let's say that was good. All right, so we're very close, and so that we're going to call that good. So now that this is we've determined that this is our last point. Instead of hitting enter, we are actually going to hit run, correct?
No, actually, in this case, we are going to hit enter because it's as you can see on the screen, it says you've adjusted the set point, press enter to store the new position. So we'll do that.
So we hit enter. Okay, so we don't hit next.
So at this point, we're at P13. We don't need P13. This is where we'll hit run and then exit out of the commissioning mode.
So that's a little different than you might be used to with the 4000. You do hit next, but then you hit run.
Correct. And then I hit run, exit commissioning mode, my screen goes away, and now my boiler is going to be running as programmed.
So now it's an auto.
We'll hit the overview screen.
All right, so great. So now we're running an auto. So let's turn up the MV so we're closer to set point so we can watch it modulate a little bit. So as we get within 10 of our PSI because of our P setting, we should drop our modulation rate. And we're going to modulate now on our curve because it's commissioned. It's actually finished. You can see it, see it modulating on the curve. So that's actually all there is to it. So let's go right back for a second to the spreadsheet, but I think we're about ready to wrap this up. Seeing how fairly painless it can be to commission one of these. It just seems like it might be a little bit more difficult than it is. So now we're back to the spreadsheet. All the numbers are filled in. You could print this, save it for your records, put in notes at the bottom here. So everything you need to have good record keeping, the spreadsheet provides for you. Helps you through the process of commissioning as well. So thanks for watching this video. And we also have another one on commissioning the NXF4000 that's laid out in a similar manner using the same spreadsheet. And also on the channel, check out our other videos as well. And thanks for watching.